Good afternoon, everyone. Thank you so much for joining us today. We are excited to host another NOAA Innovators Series talk. But first up, some logistics. I'm Katie Rowley. I'm the Outreach Librarian for the NOAA Central Library, and we are hosting this today on GoToWebinar. This event is being recorded, so if you miss any of the talk or if you want to share it with colleagues later, we will have it up on our YouTube channel after the event. You are muted as an attendee, so if you have any questions, please place those in the question or chat panel. If it's a technical issue, like you can't hear or see the slides, try logging off and logging back in. That usually solves most problems with GoToWebinar. If you are still having issues, you can send me a chat message and I can try and troubleshoot that with you. If not, as I said, we did record this, and if you are unable to get into the webinar, you can watch the recording. We will hold all questions until the end of the seminar. And with that, I'm going to turn it over to Tiffany House to introduce our speaker.
Thank you, Katie. Hello and welcome. My name is Tiffany House. Before I introduce the speaker today, I wanted to tell you a little bit about this series. The NOAA Innovative Series features NOAA and SBIR funded technologies, NOAA employees and SBIR principal investigators who do work relevant to NOAA's mission present their research to other NOAA employees, external partners, federal agencies, and researchers. So this series doesn't just benefit small businesses, it benefits NOAA. The SBIR program is a highly competitive program which enables small businesses to create innovative products and services that benefit the NOAA mission and are responsive to greater market demands. Today, Andrew will present on Kelp. Kelp is a remote situational awareness buoy for coastal, inland, and aquaculture intelligence. It is a self-powered, compact, and easy-to-deploy buoy carrying Wi-Fi, LoRa, and SATCOM links to provide the user information at their fingertips on a smart device. The Kelp buoy currently measures dissolved oxygen, salinity, pH, and temperature underwater and has room to scale to additional sensors using architecture, electronics, and software. The platform has already been deployed and is ready for its next phase of development. Andrew Streett directs the SwiftX division at Swift Engineering, focused on next generation autonomous systems, robotics, machine vision, and digital acceleration, and their exit to the market. He leads the very talented team behind the Kelp platform, who have been able to deploy with federal MPAs, commercial aquaculture, NOAA's NMS team, and municipality levels, harbors, and bays. So without further ado, I'd like to introduce Andrew Streett.
Thanks, Tiffany. Wanted to thank both Tiffany and Katie for putting these together. I really appreciate that. And as Tiffany mentioned, we're producing. We are on contract for an SBR Phase 2 for the Swift Kelp, which is a remote self-powered buoy for water quality monitoring. Before I get started here, our team here has been diligently working here for the last couple of years, putting together this type of technology and looking to the NOAA community and also the commercial community for outlets for where this takes us in the next stage. And thank the team here at Swift for supporting a lot of this technology, and also thank the NOAA team at Sea Grant for the opportunity to work on this. And specifically, they're our technical point of contact. I saw Doug's on the phone, so thanks, Doug, for all the help here and getting us aligned, and specifically working with a lot of the community here, probably that are on this phone call, and moving it forward. There it goes. So I'll talk just real quick about Swift. Swift Engineering, we're here in San Clemente, so we're halfway between LA and San Diego. We've got about 130 people here, and we've been around since the early 80s. We've developed quite a few system level designs and advanced vehicles over the years. Coming into the 2000s, we went from automotive to aerospace. Aerospace then turned into systems engineering. System engineering turned into larger vehicles in the 2014, 2015 timeframe. We started working robotics and other software platforms in 2017. And as we go into 2020, we start looking at other autonomous advanced vehicles that we're working on here. One of them being the Swift Kelp maritime buoy that you see there at the bottom right. So there's quite a bit of heritage here in terms of the types of vehicles or the types of technology we work on. And there's quite a bit of cross-pollination, if you will, between the platforms and how this platform has kind of emerged from that type of work that we do here at Swift. Let me start here with a broad overview of the Swift Kelp product and service that we're going to go over today. In the large picture of this, there are multiple kelp buoys that can exist. Those then measure a certain amount of sensor data, and we'll get into that in a second. They transmit wirelessly over multiple wireless technologies. So we have Wi-Fi and Bluetooth on board, LoRa, and also a satellite communication link. All three of those are for different varying levels of integration in the final assemblance. So think of Wi-Fi and Bluetooth being either close to a dock or something that you may have that access in short range. LoRaWAN being something that is a little bit more readily available and easy to integrate for something that's maybe close to shore, and satellite communications for things that might be more remote. The information is then transmitted to cloud storage, which allows us to pull it on any smart device. And so very quickly and rapidly, and we'll show you here an example during the presentation, that we're able to take the real-time data that we get and display it in real time and be able to understand the different metrics and the different metrics from multiple platforms. So not sure what happened there. There we go. So we're able to take this and bring it from the cloud into your smart device, whether it be a tablet or a computer or your phone, and give you instant access to the data that we're collecting on board these kelp buoys. And ultimately, that data then can be exported and utilized in various ways for post-processing and identification of how that affects the community that it's in. That picture isn't necessarily our picture. It's a picture showcasing how big data can be utilized to classify certain regions or areas and different things that could be happening. So in general, that's the architecture that the buoy, the kelp buoy, provides. On the left, in the upper left, we have the different sensors that we've kind of gone in on for the minimum viable product here. That involves dissolved oxygen, pH, salinity, temperature, GPS for both the real-time clock as well as the location, and we've done some wave data. So those sensors on board allow us to transmit over the wireless networks, storage on the cloud, access through your smart device, and then utilization of that based on the user profile and the access at that level. The kelp buoy itself is about 30 inches in diameter, and it's about 26 inches tall. It has 4 solar panels on the top surface. It has batteries internal, so the power subsystem is fully self-contained as solar and battery. The sensors are all contained under the waterline, but just recessed from the surface of the buoy, so that as you're deploying and moving it around, there's no chance of damaging the sensors that are on board. The batteries are contained at the bottom, which gives you the natural stability of that buoy and the weight, CG lower than the center buoyancy. And most of the electronics are located at the top, which allow us to broadcast, based on these wireless technologies, back to the end point for the user. So the Swift Kelp product, it's a solution for coastal, inland, and aquaculture markets. The original solicitation for this through the Sea Grant group was for a low-cost water quality sensing device. It was very broad. And in terms of low cost, there was a way to drive that cost very low with only one sensor and very low cost manufacturing. But as we learn more about the markets and the commercial potential and how things emerged within these 3 different markets that we were looking to service, it became apparent that we could add additional sensors for fairly low cost, additional capability, and utilize the electrical power system and the mechanical system that we had developed to integrate multiple sensors. That then allows us to think more broadly as Kelp as a modular and scalable platform. So we haven't seen a lot of solutions that allow for this, and also the ability to get back to real-time monitoring, setting flags, understanding anything that might be happening there. And for that remote situational awareness, we can then do it for multiple markets, as we show here with coastal, inland, and aquaculture. The whole buoy system takes approximately a few hours to assemble the entire buoy. So one of the ways that we drive the cost out of the equipment is to reduce the amount of touch labor and assembly time, integration, and test prior to it leaving. And so with that, we're able to batch process some of the sensor calibration things we do at the lab, installation, and then we've streamlined the acceptance test procedures we do, and then the test procedures, once deployed in its health monitoring system. So we've been able to drive quite a bit of cost out of the fabrication, and then ultimately we'll show a service model associated with getting the data out that also allows for reduced costs. So again, that's how you get to those low cost numbers, is you remove the labor, the touch labor, as well as increasing the capability where we can put in additional sensors, provides this platform as a kind of a unique identifier within these different markets to provide the modularity and scalability for other sensors or reduced sensors or streamline communications back to the end user of that data. So how does this impact the NOAA community and that commercial, global markets? So I listed a few here. There's quite a few more, but this at least gives kind of an overview of how this may affect some of the teams that are even on the phone and may spur some questions on how to utilize the buoy. So within maybe the Sea Grant community, there's some low-cost designs for those educational tools or citizen science. We're looking at multiple locations for that and taking a look at the programs that are there and understanding how it could be potentially integrated. At the National Marine Sanctuaries level, we have been working with and talking with some marine protected areas, some MPAs, and monitoring them, as well as the estuaries and tidal lagoons. There's quite a bit of stratification and science that takes place within those estuaries and tidal lagoons that this is a unique solution in terms of surface measurements and additional measurements that could be taken in the future with maybe an additional product increase where you could do profiling or even static profiling over time. And then that real-time monitoring data infrastructure can be utilized to get the data back to, again, smartphones or some device, a computer. Fisheries and coral monitoring. We're looking at water quality monitoring for these types of markets or even stationary waterways for that. We've got environmental impact studies. There's a couple of unique things in terms of pre and post monitoring for environmental impact studies that this could be very useful for. Consider wind farms or aquaculture in terms of how the regulations are taking shape and where the next steps are for understanding the environment prior to installation and then after installation, and that affects not only maybe the water quality, but it also affects other environmental factors that we could be looking for testing with maybe an upgrade on sensors for this. We also look at dams and reservoirs. They collect water from multiple sources upstream, and so this is another way for the team to be able to understand the collection of those different waterways and how that's influencing a larger semblance of those waterways. There's things like salt runoff in terms of environmental impact studies also that seem to be a big task for certain scientists to do over the time frame that there's salt introduced in the environment. And then also we're looking at some hazardous waste identification. Now this would be a future capability, but also something to maybe talk about or discuss at a future time. And finally, commercial aquaculture. There are things for coastal and weather forecasting, environmental awareness. And again, we've got a lot of questions about the HAB type environment and how to maybe monitor other types of nutrients and things that could, again, be kind of a future upgrade to what we're currently looking at that could ultimately provide data for future situations and trying to be proactive about environmental changes. So how do we get this to the end user? We are seeing that data as a service is probably one of the more reasonable ways to get this data to the end user. We've abbreviated that as the DaaS acronym there. Basically, that breaks down to a monthly fee. It includes maintenance. It has no extra data fee charges. Everything's basically in one wrapped cost, and ultimately provides that customer service to replace the units that might have had issues or data that looks a little bit different. And because of the cost and weight of these buoys, we can ship them pretty much anywhere, we'll say domestically, overnight or within a couple of days. So we can be a very rapid response to having maybe a centrally located repair location. And then the deployment of these items can be rapidly deployed to fix any types of issues and then bring the old units back to fix them and work on them. In terms of products, we also would be able to provide that same service in terms of product, but maybe that involves changes in sensors or anything that might be a little bit more out of the ordinary. And we don't really find too much in this class from a commercial development standpoint. There are probably other development platforms that are maybe in and around this size class, but we don't see a lot maybe in the commercial development side, and especially with like the open architecture, we're really trying to bring to this buoy development custom electronics packages or ICDs, interface control documents, so that scientists can be able to work within the system and not only purchase just the system. So we're trying to create an ecosystem here that allows us to merge in some of these other open source programs or projects and how to contain them in a platform that can be modular and scalable. So we've seen other, in other industries, we've seen some of this data as a service being helpful. So we work in the unmanned aerial systems category. So on the UAS side, we do see they provide drastically lower life cycle costs for those product lines, mainly because it removes a lot of human time and energy trying to collect the samples and provides real-time feedback. And the real-time feedback provides health metrics, so you know almost instantaneously when you have any issues of what's going on in that area. We do see that some of the governments, organizations that we've talked to, and it doesn't mean we've talked to everyone, but in those ones that we have talked to, that they want the data and not necessarily the maintenance costs of the system, again, kind of reverting back to that life cycle cost. We do see at low cost, it allows for rapid expansion and ease of maintenance cycles. And so we can start to plan those better and start to align labor to handle the amount of buoys that are deployed and probably in a certain type of rate that ends up having to go through maintenance cycles. We do see on this buoy that between 3 and 6 months, there is potentially a maintenance cycle needed for cleaning sensors, depending on what sensors there are and what capability is requested. So I'm referencing 3 to 6 months on the type of sensors we currently have. So ultimately, if you have less overhead on the team that needs to measure things, you can create more impact. So the concept here would be that the real-time data collection, without having to go out and physically collect it or know when something's wrong or know when an anomaly takes place, that would then create additional data, but also additional human time to do other useful tasks or valuable tasks. And also we see that the commercial companies we've talked to, many of them also want the data, not really the actual physical device. And they want to be able to work with the upgrades and just have them kind of seamlessly integrated in what they're doing. So we do see, providing that data direct to those groups is also a benefit. And of course, like I said, product sales do exist to fulfill kind of unique use cases. And so we try to service and understand both of those two sides in what we're putting together. Just on the bottom there, the buoy, goes to the cloud as we showed. It then gets displayed on the smartphone device, and then ultimately to the location, the web portal interface that we have. So I'll go here and talk about some of the user interface work that we're working on. This is a snapshot of one of them. I can show you kind of a real-time one here in a second. Basically, for this particular product, this is just a snapshot of one of our recently deployed buoys, and we've got water temperature, dissolved oxygen, connectivity, and pH shown over time. And if we go into the web interface, set this up. Just 1 second. Tiffany, could you just confirm that you're seeing?
Yes, I can see it.
Okay, great, thank you. So this is just an open view of what the environment looks like when you go into the web portal. We've got a summary in the upper left, a map in the upper right, and then a series of these metrics over time. And you can see this is in real time. We're measuring, if we look at, start at the top, we look at temperature, it's 57 degrees F here, looking at just south of Oceanside near Carlsbad. So we've got in Southern California. And so we've got all these series of metrics, and some of the things that we look at here, you might want to look at a little bit closer. And so say we look at the pH here in this section just before the nighttime here on February 8th. We can start to understand different locations when these were taken and what's going on, if things are moving, what do we want to do to look at it in more detail. We can reset that zoom back to the original size. All of these charts are modular. You can move them around. You can change the look and the feel. You can set flags or alerts for these types of things. And that allows information flow and information gathered to be more seamless and easier to interact with. So we see these different windows being architected based on the capabilities of Buoy, and it's very simple to pull in different types of metrics or different, maybe there's post-processed data based on these metrics that is valuable. It's fairly easy for the user to jump in and change those and bring forth maybe post-processed information. Maybe it's something to do with tidal flow along with these metrics that, bring in some sort of, equation from those metrics, those inputs. That output can be very valuable. So this kind of interface allows for the user that's signed in here to access all of their data in different areas. It also can access multiple Kelp units. So although we're showing one here, this system has the ability to scale to all the buoys that you might be looking at and bring forth all of that data and then ultimately post-process that data in a certain way. So we're looking at ways to bring multiple buoys online here at the end of our phase 2 in an effort to close kind of that initial phase 3 discussions that we've been trying to put forth. So I'll switch back to this. Tiffany, if you could just give me a yes that we're back on.
Yes.
Oh, great, thank you.
Perfect.
So again, just to summarize that, the web interface is something that you sign into. You have a user account. You're able to utilize that across different platforms. You could store old data. You could bring all the new data sets. You could access it from multiple places in the world. You can also set up these warnings and flags and alerts so that they're based on user-defined needs. And obviously, that's going to be individual to the different teams that are looking to utilize this kind of technology. So finishing up here in phase 2, as we get into kind of mid-2021, we are finishing up and completing some major milestones. And so from the program level, we've designed, analyzed, and fabricated multiple prototypes that have been tested. And so not only from a system level test, we've also gone into drift and maintenance, line replaceable units, and looking at the calibration testing that has to happen prior to release. So we have gone through, we have a bunch of test data on that. In some of our worlds, they're maybe called qualification tests to get this out into real world use. But obviously we can tailor that based on the sensors that we want to bring in future-wise or in the existing set we have. We did design all the buoy components, fabricated it, did all the transfer data. We have multiple buoys showing up within the user interface, and then obviously accessible even in this kind of environment, real time with the team that we need. There are multiple buoys that have been connected to the cloud, and then this other item, which is a significant reduction in the cost associated with it. Again, we put these together in a matter of a few hours from the piece parts that come in. Again, we've manufactured most of the piece parts to be as low cost and line replaceable as possible, mainly because you could rework some of these if in the event that something internal fails. Most of the structure is probably still intact. You can rework those and utilize them for maybe other avenues or even into philanthropic avenues if they kind of are longer in their life cycle. And then phase 2, successful market entries. We've talked with and been able to deploy with quite a number of, we'll call them beta customers. They're not paying customers, but they're giving us very valuable feedback in how we can operate, how we deploy the data, how they access it, looking at the data from their subsets and confirming that it's accurate to what they're expecting. And then we're looking at closing this phase 2 out in the middle here of 2021, and are kind of in this process of looking for additional phase 3 or other types of questions and areas that we could get involved with. So let's talk a little bit about our deployment. So in terms of our deployment, we've been working with a couple of groups here in Southern California. That obviously allows us, there's an advantage to working here in Southern California. We live and work here, so we can access and make changes if we have to do firmware changes, or we have to do sensor calibrations, or we have to check multiple buoys. We can check them based on the other buoy networks that exist already to confirm how they're doing. So we're working with the Channel Islands Marine Protected Area Zone up there. So I don't know if Chris and Ryan are on the phone, but a lot of thanks to them for helping and working with us on permits and applications and deployments. Really, really great story there. Big success. We've worked with Jeff at the Los Penasquitos there, an estuary here down in Torrey Pines. Great success there. Huge help from the team. We looked at a couple of state fisheries and we've looked at, we're currently in the final application process for deploying in Mission Bay. Again, if you look at the semblance of these, it kind of helps bring forth more, the more applications we can get this involved in, the more user feedback we're going to get, and the better refined we're going to make the end user experience. But also we're going to understand any anomalies or issues that might pop up from a sensor standpoint or a maintenance standpoint, or how we can get these out to multiple customers working multiple applications. And we also have a commercial aquaculture group. So what that allows us to do here is that we've worked with now federal agencies, state agencies, city agencies, and then also we've worked with commercial organizations as well. So we have the rollout plan is that we have 4 customer trials that have began late last year. You can see kind of the initial locations there on the map. We're going to provide probably close to 12 months of data delivery and maintenance and service, working with those groups to try to understand how to service, what we can do to make it easy. Again, looking mostly at this data as a service model seems to be the easiest thing for the teams that we're working with to use the data. And we're looking at a team that wants some hardware deliveries and a couple other ones that are looking at this data as a service kind of plan. So here's some kind of unique deployments that we've had. This is off the Channel Islands here. Worked with them and figuring out how and what that use case might look like, and how current and future states of the buoy might help within the MPA there, and monitoring water quality, runoff tidal flow, and generically currents and other things that might help real-time data assessment of the area and what the scientific community there is looking for. As I mentioned, Chris and the team here, Jeff and the team here, we've worked with at Los Penasquitos, looking at the stratification of the different tidal lagoons and the estuary teams. There's actually, quite a significant amount of these types of areas across our domestically, and so there's actually quite a big need for understanding this a little bit better, and how this plays into runoff and how it plays into the local communities and what's going on with them, and then also the health and the habitats that are naturally occurring around these areas. I've also been working with, like we said, with Mission Bay on this. So Teresa, if she's out there, and the team, the Audubon Society, we've been really working well with their team. Isabella, if you're all here, appreciate all the hard work and help for that work. Really interesting to be able to deploy in a more public area, and acknowledging all of the permitting process and also the logistics and organization of doing something like that. And then also some work here with some aquaculture teams to understand what kind of monitoring they can utilize. And again, dissolved oxygen, pH, salinity, and temperature are kind of some of the items you might be interested in there, but also getting feedback from the teams on what else would be interesting and how else could we utilize this platform in a way that would be very valuable for the teams to post-process data and understand their environment even better, for either looking at the future environment that might be coming down the pipeline, or looking at past data to understand anything that might have happened previously. So again, we've looked at for the program, and this is kind of just kind of finishing up here. We're looking at some commercialization plans, looking at phase 3 type work, and the commercial aquaculture, the environmental impact studies, environmental monitoring, fisheries, estuaries, MPA monitoring, and looking at existing and future infrastructure. Again, thinking maybe large items or energy generation. There's pre and post information that needs to be involved there. So we're looking at kind of all of these areas. It does seem like the data as a service is something that is frequently brought up and is helpful in this environment. So we've been looking at that as a way to deliver the information to the end user. And if you look at things kind of coming up in the pipeline, how else, so on the kind of technical side, the satellite constellations that exist, there are different satellite constellations that are coming online, and we've been in touch with them based on kind of our whole product portfolio here at Swift, but are in touch with them in terms of costing and integration. And so we're looking at how we can integrate those other new technologies as they come online. We're looking at, we had some questions and interest in maybe larger power sources so we can have increased capability and duty cycles for the sensors. We've looked at things like adding acoustics or RF or vision processing on these buoys, and so interested in that. And we've also worked with some open source groups like FieldKit and those teams out there that are putting together some very unique solutions for other organizations that ultimately can provide commercial customers or scientific community more leverage and more information gathering. So we've already executed. I know NOAA doesn't necessarily have a phase 2E, but we've already executed phase 2E and phase 3 contracts with other groups. And so we understand the template for how to do that and kind of that recipe, if you will, for success. And based on this conversation and interest or maybe follow-ons, we're also looking for phase 3 partners to continue this into the next phase. And so with that, I'll break. I know we're trying to keep it kind of to a half hour, so I think that's a good place here. So Tiffany, I'll turn it back to you, and maybe we can answer some questions.
Great, thank you so much, Andrew. Okay, we do have a number of questions, so I'm glad you ended when you did, so we can get to some of them. So the first question we had that was asked early on in your presentation: who is the buyer of Kelp?
Yeah, so we in this presentation we outlined some of these groups may be interested in purchasing data. So that might be something that comes across as maybe a monthly subscription to the data, depending on, again, we're kind of moving forward with a first product here with a certain set of sensors. And so we've got some buyers of data here. And I think here I talked a little bit about whether it be federal, state, and city as initial buyers, but we do have commercial companies that have been looking at this. And so the commercial companies are also interested, again, not necessarily keeping up with the latest buoy product itself, but more in terms of the data and how they get the data and how to use the data reliably.
Great, thank you. Okay, so our next question is, are these surface-only measurements, or is the scalability include the water column?
Yeah, that's actually a really great question. I alluded to it here in the presentation. We've actually been asked this many times. Currently, right now, we've been under a scope of work to contain the sensors within the Kelp buoy itself. And so the sensors, as I said, are located just slightly recessed of the bottom surface of the buoy. Again, to protect them, but also to be able to get good measurements of that surface water quality. Our future state, we do recognize there is a need for a profiling and either having static devices at certain depths connected, maybe through mechanical strong connection, and then having an electrical wire connection as well. That has been a topic of conversation, and so I would encourage anyone that might be interested in that to reach out, and maybe we can discuss other applications and how that kind of converges on our next set of development we're looking at.
Great. Okay, I am going to turn it over to Tiffany, who had a quick question.
Hey, Andrew, I had comments and then a question. First of all, I wanted to say this was a great presentation. I like how customizable this product is, and you've worked with a lot of people who have really been able to provide a lot of help, and that's great. And even getting that feedback without, even the customers giving that feedback without paying, that's awesome. You're doing what you're supposed to do. I was supposed to do something that I didn't do, which was mention that this technology is available for phase 3, and what phase 3 is non-SBIR follow-on funding, and it's oriented towards the commercialization of the SBIR research or technology. And once an agency determines if the SBIR company is available, capable, and willing to perform the work, an agency may award a phase 3 to a sole source procurement, which you did mention in your presentation. And I'm actually interested in seeing the template that you have. So I will talk to you after this presentation.
Yeah, thanks, Tiffany. And reinforcing that, I think that's an important part of this presentation is we've gotten to a certain point in the technology development that we are available and open for that phase 3 kind of work. We have successfully navigated those in other contracts and other forms, so we have a pretty clear idea of how to make that happen. And Tiffany, welcome to talk about that. Feel free to contact me. But if others have that same thought, feel free to reach out.
Okay, thank you. And my question was, how many people do you have on your team, Andrew? I don't know if you mentioned that.
Yeah, so we have approximately 4 or 5 really strong engineers on our team, mainly focused on the major verticals. You've got mechanical, electrical, software, you've got system test, and then kind of deployment testing. And in this case, it's maritime testing, I'll call it, but basically deployment and post-processing of the data and feature requests. So similar to a lot of the different groups we have here at Swift, we set it up kind of the same way. And in an effort to keep within the cost structure of the NOAA, we utilize various partners for collection of sensors and things. So I'm not including maybe a few contractors and things outside of that main group.
Great, thank you. Okay, I'll turn it back to Katie.
Thanks, Tiffany. Our next question is, forgive me, everyone, we will go as quick as we can, but I'm going down the list of how they were submitted. So our next question is there any data processing on the buoy, or is raw data sent to the cloud?
Yeah, this has also been a topic of pretty interesting, kind of next technology development. Here at Swift, we work with post-processing of data sets, whether it be digital signal processing or machine vision type neural nets. And so this has come up from that topic. And so we have a lot of statistics and data on how much power consumption there is for these types of units to pre-process the data before sending it. We also have a partner group that we've been discussing with that can provide further compression and digital acceleration, if you will, back to the end user through SATCOM links, maybe different than Iridium. You can use different SATCOM links for that. So we have been in discussion about whether we post-process the data on board and then only send statistics, or we process the data at the end location, maybe in the cloud. There are pros and cons to both of those. We see kind of the scales tipping more towards processing on the buoy, which may require a little more power, which again, because we've developed this buoy in a way that can be scalable, we can add much larger power sources on it pretty quickly with the same architecture. And again, less than a day kind of integration and deployment. So I think there's pros and cons to both of those. If you have kind of an application you'd like to discuss that could process the data on board, we have some of those facilities and experts here at Swift that can help discuss that in a little more detail.
Thanks, Andrew. Kind of following on that, the next question is, who is the satellite provider transmitting the data, and is the data transmittal included in the bundled service?
Yeah, so that on the data as a service kind of monthly subscription fee, yes, everything would be included with that in its current form. If we start streaming massive amounts of data, we might relook at that. But again, most of that has been tipping towards the scale of processing the data on board the buoy. And currently, right now, we're using the Iridium constellation. We have access to a couple of the different constellations that are out there, and even there's a couple of other constellations coming online that we've been discussing with as well. So right now, just standard Iridium, but looking forward to the opportunity to look at other new LEO constellations as they come online.
Great, thank you. And now moving on to a little bit more practical things. What is, you may have mentioned this, but what is the dimensions of the Kelp buoy?
Yeah, so the Kelp buoy, it's about a 30-inch diameter, about 26-inch height. It weighs just over 50 pounds, 55 pounds, and is easily deployable by 1-2 people out the back of a ship. We've got a couple of deployment concepts, but that's how we've been doing most of our initial phase 2 work right now.
Great, thank you. Next question. Any plans to put buoys in polluted waterways, especially to see positive impacts from restoration projects?
Yeah, that's a great question, and we've been asked this multiple times because I think the size and the scope of what we have here lends itself to helping with these kinds of projects pretty quickly. And so we are very interested in helping to find a way to create that positive impact on those restoration programs. And so if you have anything, my contact information is here, or you can contact Phil, either one of us, and we'll get back to you on how we can help provide that impact.
Great.
Oh, Katie, did we lose you?
Oh, you did lose me because I muted myself. So sorry. Okay, how variable is the LoRa WAN, if I'm saying that? How variable is that coverage inland or across North America?
Yeah, so that RF technology has kind of a limit on its max range. And so there's, again, like I said, there's 3 technologies on board to try to cover as many use cases as possible in these original product outlay. On the LoRa side, we have the ability and have it integrated to the LoRa systems, and there's kind of an easy way to do it. There's a couple of key products that we can bring in on that. In terms of coverage inland, it really needs to have a base station or some sort of network, and I believe there's actually a mesh capability to it. So you're going to have you have to be in range of the base stations or network to receive that signal, as opposed to satellite communications, which allow you to be more remote, away from maybe those initial base stations that may limit remote inland locations. And so that's actually why we developed the Kelp buoy with multiple communication devices on board, is that we wanted to provide the community with a way to not have to utilize satellite communications because maybe it's bandwidth or something else. Maybe you want to post-process at the location and you just want to tie it to a dock. So we wanted to open up the ability for the community to also look at this as a way to change the concept of operations if they wanted to. So in terms of the coverage, I think for LoRa, it's really focused on where your base stations are and how you can receive to them.
Great. Okay, I'm going to hop around a little bit because there's another question that's related. How far offshore can the Kelp be deployed, and is there a limitation on the web connectivity?
Yeah, so again, kind of coming back, that's a good kind of follow-on question. So coming back to the same concept of, think of the Wi-Fi and Bluetooth being something like dock, on your dock or something, close to shore where your Wi-Fi signal can still get to it. Again, assuming the router is close to the dock. Think of the LoRa connectivity as something that maybe is within a half mile or something of your location, a quarter to a half mile, where you can get the reception and you can buy the base station to be part of that solution set. Satellite communication really covers the rest of the globe associated with getting the data back. So can it be deployed in more remote locations? Yes. Does it have to be? I think most of our applications right now, we've added a a mooring to it, mainly because we're going through development tests. We want to make sure that if we have a firmware update, or we want to make changes to it, or we want to bring in a different duty cycle or something where we influence the user interface, we want to be able to make those changes rapidly within the phase 2 infrastructure and then deploy it rapidly. And so that's why you see a lot of these things in moored positions, but it could be free floating. I think we find that some of the applications that seem to suit this really well, kind of reverting back to the restoration projects and estuaries and tidal lagoons and aquaculture, some of those being a little bit more closer to land as opposed to really remote situations.
Great, thank you. And also related, our next question is, how is IT security handled with the use of Bluetooth, Wi-Fi, and LoRa when it comes to complying with NOAA IT security policies and regulations?
Wow, that's a tough question to answer in a 10-minute session. I'm happy to talk through those things. I know there are certain protocols and policies in place with the different government organizations that we have to look at. We follow government standards here at Swift, and also with our unmanned systems. We have certain encryption requirements and data handling policies. However, as you can recognize, this is not only at our location and not completely controlled as easily. So there are some things in terms of policies and integration that we probably want to look at maybe in a phase 3. And so this is a good opportunity to talk about how we could influence our phase 3 scope of work with maybe some of these organizations to focus and clearly identify all the requirements and make sure that all of those get handed off into the next scope of work. We can go through kind of our high level information, but I think at the end of the day, each organization is going to have something slightly different. And again, we have a lot of those hooks in place here, but ultimately have to read all those policies to really give you a straight answer on how to do that.
Great, thank you. Talking about phase 3, would you consider partners outside of California, specifically here in Maryland?
Certainly, yeah, and actually that's one of the reasons for reaching out here is, Tiffany and Katie, this is extremely helpful, and Doug has been very helpful as our technical point of contact to getting organizations involved and discussed here, and trying to get the word out on kind of what we've been able to put together here. So we're very interested in looking at other locations, and I think what we're looking for in a phase 3 is how do we solve something valuable, and how does that application fit, and is it something that needs to be changed, different sensor, different semblance of sensors. But I think the larger architecture of what we showed today, we'd probably keep that similar in terms of the backhaul and then how you interact with the data. So where you are physically located is not as intimidating. Again, we can ship these from our location to there and can have a local contact for maintenance, and we'll call it line replaceable unit type stuff. So we do that with other types of things we do here at Swift. So it's definitely open for conversation, and I encourage you, again, my contacts here, Phil's contacts here, if that person you mentioned that question would like to connect with us, we can help discuss any questions there.
Great, and since we are running on time, there are a few areas I do want to hit on. First up, I don't know if we missed this, but can you give us more information on the target purchase cost and ongoing operating costs?
So in terms of the costs, I think what we want to do is look at all the applications that come into a phase 3 and how we can influence kind of that next stage of development. We think this product has the potential to get out there and do valuable work. We have also found, though, like some of these questions in terms of profiling, adding something very simple like a depth finder, or adding a few 1 or 2 additional sensors for post-processing. We have found that there's some small tweaks on the buoy that could be very valuable for certain groups. So in terms of cost, I'll probably hold off on answering that directly as we start to move into phase 3. But as you can imagine, we've pretty much taken out all the costs we possibly can. We've merged this into a couple of hours of assembly. We can deploy it very quickly. We can ship it around the country very quickly. And at the same time, all of the cost components are derived in a manner that it's very quick. days, if not weeks, if not days, to get these components in-house. So everything is put together in a manner to drive the cost out. So you're going to find the costs are very low.
Great. Last question, I'm going to try and combine two questions, is when you say customer service to replace units with anomalies, does this mean an exchange program, or do you have a global service partner to set and replace these for the end user?
Yeah, this is a good question. So we, when we talk about something that might happen as an error anomaly, most likely, if it's 1 out of 100, most likely we would just exchange it and bring it back and change that and make that change or remove the components, put new ones in, and be able to redeploy it. So that's kind of the initial concept operations. Again, until we get to that size, though, we'll probably be working with local experts or trained, consultants on staff in those locations. But then as we grow larger, you're probably going to end up with more of a global coverage network partner to help with that stuff.
Great. Along those lines, biofouling is a major problem for these kind of applications. And while our asker loves the DaaS concept, long-term deployment is likely to require a lot of hands-on work. How do you imagine handling that?
Yeah, so that's actually part of the maintenance schedule that we tried to build into the business plan and the financials early on, knowing full well that we're going to have some level of either cleaning or replacement. So the buoy itself is designed to allow easy access to sensors to clean them, and also for the ability to possibly recalibrate or whatever the maintenance schedule requires for the type of sensor in there. So for us, we're looking at a 3 to 6 month time frame for that maintenance schedule. And again, you're looking at a device that you could ship back, have it cleaned, and ship back to the location fairly quickly, and put one in its replace it as it goes. If you're talking about really remote applications, that could be tricky, but I think most of the stuff that we're talking about in terms of coastal, inland, and aquaculture type markets, they are at least an initial seeding point. They provide an application outlet for the technology that you can quickly get to and service and maintain them over time. So we're probably going to favor those applications maybe first, just so we can get those bearings and everything up and running, and then start to take on more challenging things as we get going.
Great. Okay, we have a ton more questions, so I will keep your questions coming, and I will record all of these and share them with Andrew after the seminar, and then share all of these questions and answers with everyone who attended today. But let's try and get 1 or 2 more in. Are there plans for an API if users would need to see Kelp alongside other types of buoys?
Yeah, that's interesting. We did have a request from an existing network of underwater sensors and network, and how to maybe correlate and look at those in conjunction. I think there's an opportunity here in a phase 3 to look at that a little bit closer. And so I would encourage the person with that question to see if there's maybe something to do that, because I think the intent here is to complement the existing infrastructure ecosystem and provide additional tools into that. And that intent involves this kind of collaborative environment. And I think we see not only is there some missing databases, opportunities out there where just collecting the data and providing it is a value to maybe the organization, but also looking at past data sets or other applications at the same time can help. So we do have an opportunity. You can export the data and utilize it somewhere else. That's part of this ecosystem. But I think we are interested in ways to merge and see these things in real time. I think you can imagine tidal flows and things like that would also be part of this, or maybe sun cycles or something. There's different things in terms of environment that affect it, and we'd like to see that kind of information overlaid here, and are looking for opportunities to include that maybe in a phase 3.
Great, we are right on time, but I am curious about this question. So what temperature range has the Kelp been designed for? Could its structure withstand ice conditions?
Yeah, this is a difficult one. Currently, right now, it's not specifically designed for freezing Arctic type conditions. I don't think that's out of the question. Again, looking at phase 3 and kind of next level development, I think there's an opportunity here. There's quite a bit of aquaculture up north. There's quite a bit of data science that has interest. Right now, this particular unit is not meant for that kind of application, but we do have knowledge and interest to discuss that. So feel free to reach out and we can talk a little bit more about that.
Great, thank you, Andrew. This was a great presentation, but we are right on time, and I would like to respect everyone's time and let everyone go. If you put a question in and we did not get to it, I will make sure Andrew gets these questions and that you get an answer. So I will gather all these up and get them to everyone who attended. Thank you, everyone, for joining us today.
Thank you.